negative exponents, I want you to write that 2 to the 4th over 2 to the 7th using the power laws that we reviewed yesterday. So when you're dividing powers with the same base, you subtract the exponents. So subtract the exponents, that's your exponent on 2. Then in the next part, I want you to show it the long way. 2 to the 4th, what is that as a multiplication? Is it 2 times 4? Is it 2 times 2 times 2 times 2? What is it? Show it the long way and simplify that fraction. Okay? So we're doing negative exponents. Get your pencil out, ready to do it.
Okay, so simplify common factors of 2. Guys. And show with only a power in the denominator. So that's just going to be 1. And the power in the denominator is 2 cubed.
Okay, they're exactly the same question, but looking at those answers, they look different. What it tells us is they have the same value. So 2 to the negative 3 is the same as 1 over 2 cubed. So we want to be able to figure out the value of any power that has a negative exponent. We want to be able to simplify powers if they're variable bases with a negative exponent. And it's in simplest form when the powers have positive exponents. So we need to be able to know how to get from a negative exponent to a positive exponent. It means we have to flip it, which is not a math word, but that's really what we're doing. It's taking the reciprocal is the math word. Okay, so what can you conclude? They are equal, right? And so then a conclusion here underneath, oops, a base raised to a negative exponent is equal to the reciprocal of the base raised to the positive exponent. As long as the base isn't 0, right? Like if, not that we really ever show a power with a base of 0. If we had 0 to the negative 3, then that's 1 over 0, which is undefined. But really, we'll never show a base of 0. Right? So you don't really have to worry about. But it's just reminding you, you can't divide by 0.
So that's one way of seeing the relationship. So think about it. If I gave you 4 to the negative 50, how would you show that with a positive exponent? Who can tell me based on what we just did? What's it going to look like? Hands up. So negative exponent flips the base and makes the exponent positive. Who wants to test it out? What is that equal to? 2 to the negative 3 was 1 over 2 cubed. Was the 2 the same? Yes. So it flipped. The 4 is the same. What's the exponent on 4 going to be? 50. So you're done. Unless you're asked to evaluate, right? And then you would figure out what 4 to the 50th is, which probably is an error in your calculator. It's pretty big, but maybe it'll give it to you in scientific notation. So we just leave it like that. So that's the rule. Now, another way of looking for that pattern or what to do with a negative exponent is in the next set here. So 4 squared, it says evaluate. You can use your calculator, okay? Now, do you need to? Well, let's see. Let's see if we need to, because hopefully you know 4 squared is 16. 4 to the 1 is 4.
What's 4 to the 0? 1. Okay, so take a look. We are reducing the exponent by 1 each time here. What are we doing to each of the values each time? To go from 16 to 4 to 1. Dividing by 4, right? So dividing by 4, dividing by 4. So this divided by 4 would be 1/4. This divided by 4 would be 1/16. Your calculator will give you the decimal form, okay? But that's the pattern. I actually don't really want you to use your calculator in that sense. So again, that 16 is 4 squared. So that's equal to 1/4 squared. So that negative exponent becomes positive when you flip it. These have had whole number bases. What about if we have a fraction as a base? So remember, when we evaluate this, we go 2 squared is 4, 3 squared is 9. Okay, this exponent of 1 just stays the same. Exponent of 0 becomes 1. Okay, so take a look here, what's happening. This one's a little harder to see, but you are you're dividing here by 2/3. So if I show that in red, because here I was dividing by 4, the base. Here if I divide by 2/3, then that's the same as multiplying by 3/2. And so 2 goes into 4 twice. 3 goes into 9 3 times. So we get 2/3. So then we're dividing by 2/3 again. Well, anything divided by itself is 1. Makes sense. If we divide by 2/3 here, that's the same as multiplying by 3/2. Well, 1 times anything is itself. Maybe I'll do that in blue. So that's 3/2. Then if we divide by 2/3 again, that means we have to multiply by 3/2. Well, 3 times 3 is 9. Oops, not blue. 2 times 2 is 4. So that's the same as 3/2 squared. So notice the difference between this and, oops, sorry. This one and this one, they have the same value, but in the original it has a negative exponent. In the final it's positive because we flipped the base. We've taken the reciprocal. It just happens to be a fraction. Okay, so fractions, you just flip it. As long as those brackets are around the whole thing. Okay, so if 4 to the -2 equals 1/4 squared, then what is the value of 1/4 to the -2? Now our power's in the denominator and it has a negative exponent. What do you think we'll do to make it positive? If it was up top, we flipped it down below. So it was down below, where should we put it? Up top. Okay, we're just flipping it. So here, this is going to be, oops, that's green, I'll do blue. So this is going to be equal to 4 to the +2, which is 16. So let's check it out on your calculator. So get out your calculator if you have it. Look at your neighbors if you don't have one. Okay? You don't need a graphing calculator, just a scientific that has an exponent key, right? So let's do the first one. Just let's go back to the 4 to the -2, our first example. So in our calculator, 4, exponent button, whether it's Casio or TI, is that little kappa. If you have a scientific, it might say X with a little exponent Y, or Y with a little exponent X. In newer versions, it actually goes up high like that, and we put -2. Notice on the graphing calculators, the negative is different from subtracting. So the negative's right next to the enter. Enter on that, there's the decimal form. Okay, now let's check what we said the answer was. And so we can go 1 divided by 4, and you could do a squared key as well instead of exponent 2, and you should get the same thing. Okay, well, you don't need a scientific calculator. Even if you have just a basic calculator, you can do the second part because you can go 4 times 4 and then 1 divided by that. Now, on the TIs, you can actually get it to convert to a fraction from a decimal by, depending on if it's a rational number, which we talked about yesterday. If you press math key, then the first entry is arrow frac, which means it's taking a decimal and converting it to a fraction. Okay. If you have a TI-84 calculator, then you could have done the 1/4 squared as a fraction. I don't because it takes more time, but if you go alpha y equals, and the first entry, it gives you a fraction. So you can enter 1, cursor down, 4 squared. And if you do that, it gives you the fraction form right away. Okay, so if you have a graphing calculator, these are the little things. You don't have to have one, but it'll help you get used to using your calculator. Okay, so now what's the value of 1/4 to the -2? So 1 divided by 4 to the exponent -2. It's 16. That's what we thought it was going to be. So we just checked it. Okay. So the summary here, if we have a to the -m, okay, that's the reciprocal of a to the m, and vice versa. So a to the -m is 1/a to the m. 1/-a to the a to the -m is a to the +m in the numerator. We don't have to put over 1. So don't bother putting over 1 because anything divided by 1 stays the same. If you have a fraction, then you just flip the fraction and make it positive exponent m. Okay, and obviously the base can't be 0. We've talked about that. Okay, so it says here, it is common convention that we leave exponential expressions with positive exponents only. For this course, when asked to simplify an exponential expression, you must always leave your final answer with positive exponents. Sometimes we'll remind you, sometimes we won't. And so we'll be expecting positive exponents. Okay, turn over the page. So although maybe your calculator will do some of these for you, basically on a test we'll probably have mostly ones with variables, so you can't put it in your calculator. Okay, so it says express each of the following with a positive exponent first and then evaluate. So this one is going to be 1/5 to the +1, which is really just 1/5. So once you flipped it, you evaluate the power. Okay, next one. If we use our power rules, that's 9 to the -2. Then if we need a positive exponent, so that's 1/9 squared, which is 1/81. Okay, anytime you have a whole number to a negative exponent, get it through your head that you're going to get a fraction answer. Okay, take a look at this one. Did we have to even show 9 to the -2? It didn't say we had to. If you have more 9s in the denominator, you know there's going to be positive exponent on the base and the denominator. Back to that first one that we did here, there were more 2's in the denominator. So if you see that, you could go 7 minus 4 equals 3 as long as you keep that base in the denominator. So you don't have to do the subtraction first. So this tells me I have 10 9's up top, 12 9's down below, so I have 2 extra in the denominator. So it's 1 over 9 squared, which is 1 over 81. So this part is really optional for that one. This next one, same thing, it's just got brackets. So I'm going to keep the brackets. It becomes a positive exponent in the denominator. And then you evaluate that. Remember, a negative squared is a positive. In D, where is the negative? There's 2 negatives, really. So the negative in the exponent has nothing to do with the value of the base. This negative stays. It's outside of the 7. It doesn't apply to the power. So it's just negative and then 1 over 7 squared. So different from C. Look at the difference. C has brackets around the negative 7. D doesn't. Now, in E, the power with the negative is in the denominator. Okay, so now we have to flip it up. Anytime you flip from the numerator to denominator, or denominator, to numerator, I just was saying the wrong thing, it changes the sign of the exponent. So you might think I'm going to show it like that, but you don't need to show the 1. Anything divided by 1 is itself. So what's that? 8 times 8 is 64, times 8 is what, 512, I think? No? Yeah, 512. Okay, so 1 over 2 to the negative 5 will just be 2 to the positive 5. Okay, and then G gets a little bit tricky as well. Some students flip the whole thing. So notice that the negative 2, the exponent, is not on the entire fraction. It is just on the 3 there. So that goes to the denominator. There's no exponent on 2, so the 2 stays there. So this is going to be 2 times 3 squared equals 1 over 9 times 2 is 18. Okay, so you do not bring the 2 back up to the top. That 2 does not have an exponent on it, so it stays where it is. You only move things if it's got a negative exponent. Now, variables. So all of the ones above, you could check with your calculator. Okay. Won't necessarily answer everything, but you could certainly check. Although if you have math prac, it could help you out. Question 2, simplify. Leave answers with positive exponents. So, again, you could use your power laws. So that's x to the negative 3. And then to make that positive, it's x to the positive 3. Now, did you have to do that? No, you could have gone right to that because you see there's 5 x's up top, 8 down below. So there's 3 extra x's in the denominator, x cubed there. Okay, you flip the base along with the negative in the brackets. When you square a negative, you get a positive. The negative in the next one stays up top. You don't put it in brackets. I'll do that over here. So it's very similar to these two questions here, right? Except it's got y instead. So this will be negative 1 over y squared. Just like that was negative, the one above, negative 1 over 7 squared. Oops. Okay. Negative exponent on the x in the denominator, that has to go up to the numerator. The 2 didn't have an exponent, so it stays. And that's going to be times x to the positive 2. Okay. Now we're getting into ones that have negatives maybe in both. So here's the hint. Simplify using the power laws first before you start dealing with negative exponents. Otherwise, you may have to do more steps than required. So this one here, I'm not going to flip anything yet. I'm going to figure out what negative 7 minus negative 3 is, because I'm dividing powers with the same base. So I subtract the exponents. So negative 7 minus negative 3, who can tell me what that is? What? Negative 4, because that's like adding. So that's negative 4. And then we deal with that negative exponent. Oops. So that's going to be 1 over a to the positive 4. Okay. So basically, you need to know your integers pretty well. Because for the next one here, what is 3 minus negative 5? A lot of students will tell me that's m to the negative 2, but it's not. What is 3 minus negative 5? Someone else here, okay? 8. Do we have to flip anything? No, because it's a positive exponent. Okay. Next one. Take a look where the negative exponent is. It is not on the 2. There are no brackets. So the 2 stays. So a really common mistake is people will flip 2x to the negative 2 to the denominator. The 2 stays. Okay, this has to go down to the denominator. We already have y to the 5th. That doesn't move. It's a positive exponent. But that's going to be x squared there. Okay, you only move the factor that has a negative exponent in it. So here, we can't simplify this. They're not the same base, so we have to move them. So this goes down to the denominator, and this goes to the numerator. So that'll be y to the positive 5 over x to the positive 2. Oops, sorry. Oh, I flipped it. Keeps. Now it's very sensitive. Okay, there. Okay, now we're looking at fractions. So same property, it's just we have fractions, they're in the brackets. So it says write each of the following powers using positive exponents only, and then evaluate where possible. This is if it's variables, you can't evaluate anything. So positive exponent means we flip the fraction to make it positive. Yeah, you could go 1 over 7 over 5 squared, but then you have to flip that back up. So this is the easiest method. And then evaluate, that'll be 25 over 49. So keep it in brackets. When you flip it, change the sign of the exponent and then evaluate. Brackets. Now we're going to flip 3 over 2. So that's 2 over 3. It's negative, so we just leave that one negative sign out front. We flip the fraction and it becomes positive exponent 4. Then we know we're raising a negative to a negative value to a positive exponent that's even. So that means the overall answer will be positive. 2 to the 4th is 16, 3 to the 4th is 81. Okay. Let's check, get your calculator out. Let's check that one. So, open bracket, you should find bracket key on the graphing or scientific calculators. Put negative, 3 over 2, and I'm just going to use divide symbol. You can use fractions if you want. Close that and raise it to the exponent negative 2. Oh, sorry, negative 4. Let me clear that off. Sorry, bracket negative 3 over 2 to the exponent 4 gives you that decimal form. Oh, what happened here? Just a sec. I put it in wrong. What did I put in? It didn't register my negative. Let's do this again. Bracket, negative 3, divide by 2, close the bracket, exponent, negative 4. I got to be careful on this calculator. There we go. There's the decimal form. What I think it is 16 divided by 81. And it's the same thing. Okay, so that's one way to check. If your calculator has the capability, like the TIs, to put it in fraction form, I could go math and then frac, enter, and 16 over 81. Okay, if at all you round any of that, it won't be able to convert it. Question? Variables in there. So to make that a positive exponent, we have to flip the fraction. And then that squared is applied to numerator and denominator. And again, please make your exponent smaller than your bases so I can tell what is an exponent and what isn't. This, the negative stays out. It's outside of the brackets. It has nothing to do with that power. And then here, that's going to be y over x to the positive 4. So negative y to the 4th over x to the 4th.
Why does it still stay negative 1?
Because this negative has nothing to do with the exponent.
Okay.
It's just a negative value, right?
Inside the brackets, and that's when we remove the negative?
If it's an even exponent, yeah, like back in B.
Yeah.
Yep. Okay, write each of the following as a power with an integral base. And that means an integer base. Okay, so not a base of 1/5, a base of an integer. 1/5 is a rational. So an integer could be 5. That means a power of 5 that gives you 1/5 is 5 to the negative 1. Basically, flip it back up. So if we flip this back up, yeah, it would be 81 to the negative 1. That would be kind of a lame version, because really, you know, 81, we could also show it as 9 squared. So that would be 9 to the negative 2. We could also show it as 3 to the negative 4. Right? If it's a bigger number that is a perfect square or cube or whatever, then try to use a different base. So this next one with the negative, I'm just leaving that negative out front. Okay, and then this will be 32 to the negative 1, or it could be negative 32 is 2 to the 5th, so 2 to the negative 5. Okay. Now, what do we know about raising a negative to an odd exponent? What sign do you get for the answer? Positive or negative? Negative. So we could actually show this as negative 2 to the negative 5. Because when we raise negative 2 to the exponent 5, we'll get a negative answer. So either one of those, well, any one of those three is fine. And we could do negative 32 in brackets as well. And last one, we have to use integers. That's a decimal. What is 0.01 as a fraction? 1/100th. So this is the same as 1 over 100. So that's the same as 100 to the negative 1 or 10 to the negative 2. Okay. And then I guess we could have some as well. But that's where the lesson ends. So, yeah, we'll still have a bit of time. So you're going to spend some time doing the practice right now. And we'll have the quiz. This is the quiz. This is all it is. Okay? That's it. And so we'll do that probably at about 2:45. Yeah, you go down to 103. You can still go down the stairs right now. Well, yeah, of course I know. Just the video.